So this week, the lab numbers are shuffled. I'm going by what the class feels like. So this is supposed to be lab 10, but it's lab 8 now. And we're going to do transformer testing. Why do we need to do that? Because a lot of oil burners and some electrodes and also gas burners require you to have a transformer. What does a transformer do?
From high to low or low to high.
Exactly. They either step up the voltage or step it down. It works with the basics of induction, which is the same thing that's, I'm going to use that. So this charger is wireless. What is it doing? How does it charge the phone? Waves? No, it's not waves, it's induction. This is completely induction. What is induction? You're inducing electromagnetic force through steel core or something else. So the induced voltage is transformed through the core and then it's received by another coil. So the basic way to look at the induction is steel core. And we have wires. More wires means more voltage, less wires means less voltage. What is the primary? Which one is the primary?
The higher.
No, not necessarily. The primary is what you plug in, what you put. So this is the primary, place the input. Secondary. Please pay attention to transformers a lot because you're going to use them a lot in HVAC. Yeah.
So it'll be either one.
Huh?
So it'll be either one. Primary and secondary.
Yeah, depending on the setup of the transformer. So you can have high voltage going to small voltage. Example, 120 going to 24. Or it can be step up, as we see here, which we will go from 110 to 10,000 volts. 10,000 volts is very serious. So pay a lot of respect for it because the voltage is large enough that it will jump through air. And we'll see that right now. This is how you test the transformer. So by now, we understand secondary, primary voltage. We understand transformers. We understand electricity. You don't have to see it. It's induced. It can go through air. There is a magnet going in the voltage as well. So that's something also you have to pay attention to. So this technician system, it's a little bit similar to what you have in your car. In your car, you have an ignition system that ignites every cylinder. Over here, we have a transformer, and we have our two electrodes, which resembles the spark plug in your car. So the gap in here is 1/8 of an inch. Keep that in mind, it's 1/8 of an inch, and it differs from each industry to another. But when in doubt, 1/8 of an inch will do fine. If you don't have a gap, if they're too close, there will be no spark. And why do you need the spark? Ignite. You want the heat for the spark. Remember the combustion equation we had yesterday?
Yeah.
Hydrocarbon plus oxygen plus nitrogen plus spark. You always need some kind of spark which generates heat. So this is my bus bar over here, and they are supplied by electrodes and a transformer. So the transformer step up the voltage from 110 to 10,000. It's a lot of voltage. If any of these, why do we have the ceramic part? Huh? Insulation. It's some kind of serious insulation. If it's cracked, it's not conducting the same amount of voltage. So you want to check that those are not cracked. You want to check you have really good connection. Otherwise, you might not get the right amount of spark. You might have a spark, but it's not the right amount. So spark can differ by color. If you want it to be blue, that means it has the right temperature. Let's look at that again. Sorry. So we'll spend the next 4 weeks doing components of oil burners. Why? Because it's easier to interact with. The components are smart. Are small, And those components are very common when it comes to gas. So if you understand those components, you'll understand how to work with other equipment. You have a pump, you have a motor, you have a transformer, and you have an igniter. Those four things are going to supply you with the whole combustion equation. You have the fuel that's coming from the nozzle here and the pump. You have your air coming from the reducer fan over here. You have your motor running the whole pressure difference. You have your spark, so that's complete combustion. And again, if you, a lot of companies, they will ask you if you have your oil burner license, even though they don't do oil, but they just want to know that you have the basics according to the state. So these are the basics. We're going to spend the next 4 weeks decomposing these components, understand them, see what's in them, how do they function. If you understand how they function, you understand the mechanism, it's really easy to know which one is working and which one is not, and how they're supposed to run normally. For example, if you drove here every day, probably you have an understanding of how your car is supposed to feel, right? Sometimes it's grinding, sometimes it's rough, you feel like something is out of the ordinary because you've been driving for a while. It's rough, you can tell it's rough. You can tell the RPM is a little bit high. You can tell when you turn it's kind of squeaky. So these noises are an indication of something went wrong. Otherwise, you're very familiar with your car and how does it function. The same understanding you will develop if you work with boiler for a long time. You understand the grinding, the rattle, the vibration, the noise it's supposed to make. So within the next 4 weeks, we'll talk about the components, and next semester we'll actually see it running. So transformer, this is what it looks like. We have our primary coming in and the secondary. Which one do you think will have more resistance? The secondary or the primary? Based on this picture. Secondary. Why? More wire. Excellent. More wires, more resistance. This is an equation to tell you how many turns do you go. You don't have to remember it, but it is very proportional. So this is the voltage 2 over voltage 1 equal the number of turns at 2 and the number of turns at 1. Doing this equation, if I want to get 10,000 volts, I'm going to have to go 690 turns. So that's why this transformer is huge. It has 690 turns of copper inside. This transformer is sealed. You're not to fix it. It's completely done, and it's completed with tar or wax and sealed. You just test its output and input. If it's bad, you have to change it. They're not cheap, they're expensive, around $150 to $200. However, they are very reliable, and they last for a long time, and they give enough power. They have been replaced in some burners with electrodes, electronic ignitions, but I've seen in a lot of places they're going back to transform. They give you reliable output. So we'll talk about this and how we test it. So electromagnetism again, induction. So I hope you understand what induction means. We're inducing EMF into an object, and that's the basis of wireless charging. Iron core and copper wire. You see iron and copper interact in a very dynamic way to change movement, to change current into electromagnetic force. 120 volts to 10,000 volts. So electronic transformers for solid state, they can go up to 140,000 to 20,000 volts. Those are electronics, and they are not to be used for a long time. They just use a spark for a small instant and goes up. If you notice, again, electronic transformer becoming more reliable, and they're used in cars. So back in the day, we had a coil in the car that generated 20,000 volts for the spark plugs. Now you have a coil in each cylinder. So the process has been changed based on the reliability of electronic transformers and the speed and how fast you want the spark. So this is how it looks like inside. Secondary coil and primary coil, and we have our iron core. You see the leads? These are the leads. These two are the leads. They have springs on them. Why? Because you want to ensure solid connection between the transformer and the leads we saw before for the bus bar. So they're supposed to have really good connection. If it's tilted, it's not touching, it's not going to connect properly. Instead of 10,000, you will get 9,000, 8,000. It's not going to be high enough to ignite the oil. So this is the secondary. This is spark. You see it over here, and this is what the arc we're looking for. And this is the primary when you're putting in your voltage. So, question: can I test the voltage coming out of here using a multimeter? No. No. Yeah. Why? What is the limit for the multimeter? 600. Thank you. Don't do that ever. And there is a special.
Break it?
It will burn if it doesn't explode. It will burn probably. And it has plastic in it, it might catch on fire. So don't do that. There's a special light bulb that you can use for testing the voltage here if you want to. And there is a special tester you can place on top of it. That will test the voltage. So they are tar insulated. So if they get overheated, what happens to the tar? It will melt. It melts. It's what happens to the winding? It will touch each other. If it touches each other, that means we have less EMF, electromagnetic force, which means we have less voltage. So they are tar insulated. They can melt, and tar is also hydrocarbon, which means what? No, it is messy, but also it's good food for bacteria. So if you leave your tank in your car, you fill your tank in the car, leave the car and start for 2 years. What happens to the gas? Is it good? No. It will start to gum and decompose. If you have water in the tank, you're probably going to have bacteria eating your oil, including your gas, and have a lot of byproducts. So tar, that's why this thing is completely sealed. If you have moisture inside, probably going to grow some bacteria, and eventually it will feed on your tar, and it will function. This transformer will not do a problem. Moisture is an issue. This is supposed to be operated inside and outside. People place the transformer outside. Also, it's supposed to be in a basement that is sealed, not open, the atmosphere or the element. We have high electrical consumption for this transformer. It has the energy of 100 watt volt running all the time. So in the back, in the early time when they had a transformer, going 24/7. So doing the math for this, if you run this for 12 hours a day, probably will cost you around $60,000 a month or $30,000 a month just to run this on the whole time. The reason why they did that is they want to make sure that the oil is getting ignition the whole time. However, there is no need for that. Why? Once you ignite, the oil is going to be firing up the whole time. So somebody came, the first generation of transformers were on all the time. Second generation, they came up with something called interrupted ignition. Once you realize that there is fire inside, you stop it. And that also was an issue because if you have constant ignition, you're going to cover up any problem with the combustion. Let's say you don't have enough combustion, enough air, it will still burn, but you're covering up all the problems. So now the law and the codes call for you to have interrupted ignition. What does that mean? Once the fire is achieved, you have to cut off the ignition, which makes sense. Save money and to reduce the life of, to increase the life of a transformer. It degrades over time. Again, the tar will melt, the wires will lose its resistance, so it will degrade over time. How to test a transformer? There's a tester. There's a big machine that can test the power and give you the voltage. Do we have a tester here?
No.
It's in the test one at the top. It's big. So there's a tester where you can plug it to the transformer and it should give you 10,000 volts. But
is equivalent to 1 watt, or is it 100 watt?
say that again?
The energy of the human being is equivalent to 1 watt or 100
100 watts. If you want to say it, if you want. So you can use a tester. Okay, this is going to be in the lab, and I want you to understand what that means. This, the resistance across the primary winding, it should be 3 ohms. So let's try that. So we all know how to use a resistance, right? How to test resistance. We're gonna go into resistance. And I will use this the primary. Which one is the primary? This or this? N. So I'm going to test the resistance between the primary and see what I get. Should be around 3 ohms.
You got power to that.
No. And I get 3.2 ohms. So that's good. What does that mean? Plus or minus 3?
Plus or minus
10%.
Yeah.
So what is plus 3? 3.3 or 2.7? That is still within range. Everybody understand?
So you
Raise your hand if you
have
understand.
10% to
Can you
play
just
with.
can you just repeat it again?
Okay. So the first thing is you test the primary. No, you're just gonna put it in the top. Oh.
Basically, you got 10% to play with.
Yeah. Oh, that's also voltage. I'll show you. Okay. So we have a bunch of testers here. Pay attention. So this is the primary. I'm gonna set the ohm meter on ohms, and it should be 3 plus or minus 10%. Both. This has no battery.
No, those things are.
So I measured it, and it's gave me 3.3 ohms. So
There's some resistance.
primary 3 ohms plus or minus 10%, which means 3.3 is good, or 2.7 is good. Any lower than that, it's not good. Any higher than that, it's not acceptable. So this one will test it. Secondary winding should be around 1200 ohms plus or minus 10 as well.
What's gonna be the problem if it's higher than that?
Huh?
What's gonna be the
It's
problem?
gonna give you
if
more.
higher?
It's not doing the right
Well, I mean, yeah,
transformation. Yeah.
the transformer's not good at that point.
So now I'm gonna test the secondary. Are you paying attention? Secondary is gonna be between those two, and it should be around 12,000 ohms. So make sure you go to the leading side. Can you get another one? So you measure the resistance between the secondary, which is here, should be around 1.2 kilo ohms to 1200 kilo ohms. Okay, let's do some fun stuff here. So testing the transformer using a tester. So I'm gonna energize it. So this is a tester. It's very heavy. Not everybody carry one in their toolbox. It's around like 10 pounds, and it can go up to 10,000. So I'm gonna test the transformer.
That's a voltometer.
Yeah. That's another tester, which is basically a light bulb, very old fashioned, and you can put it in the limit, 10,000. If it lights up, that means we have power, a light bulb. But first, let me see if it even works at all.
Oh, what is that? That's stick meter.
This one is dead, Damien.
Just plug it in.
Maybe you gotta use your tongue to test it.
See? See the spot very small. Yeah.
You tell me you got double on everything?
Yeah, that's about it. So since we know you saw the spark, because you close, it's more than a spark. I'm gonna test the resistance for the second. It's supposed to be what?
12,000.
I'm getting 2,000. I mean 23,000, which is a lot. So something is really wrong with this
Is that
transformer.
voltage or resistance?
Resistance. Wow.
Double, dude.
The resistance is supposed to be around 12,000. I'm getting double the resistance.
Okay.
Something is off.
Right.
And I saw the spark was very small. So I'm gonna get another one and test it. I think I have another one also here. And this is the electronic ignition. So let me test the secondary secondary resistance. Can you take it, please? That's 3,000. Still a lot. Let's see if it goes. 14 comes in. So this spark, yeah. Why?
Should be way louder.
Yeah. It should be louder. It should be blue. I'll test the voltage. David, can I turn it on?
Okay, so, you ready?
I'll shoot. Go.
That's sketchy.
That's dope.
So it's gonna tell me 10,000, but probably doesn't have the right amperage. You know? If you look at those leads, they're designed to be set on the transformer. Let's try the light bulb. No, wait. Go ahead.
Where's it was?
So this is 10,000 volt light bulb.
Oh, it's AC.
You see how it's so small, so weak? Something is wrong with it, you know? So you have to test the transformer in different ways to know if it's good or bad. The resistance was one of the indication that it's not running very well. Okay, let's try another one. Never, if you have electronic transformer, this thing, never test it by touching the leads together. You will burn it. So, how do you test the electronic transformer? We don't. Either it works or it doesn't. If it doesn't work, let's replace it. It's not going to give you a weak spark. It's going to give you the right spark or the bad.
Give you something.
So while David is connecting it, I'm going to test the resistance. I got 1900 kilo ohm. 19,000. 19,000, which is a lot. Okay.
Ready? What's, let me know.
So how do you test it for spark?
That's the electric one?
Yeah.
Ready?
Get a long screwdriver and touch only one lead.
In the arc suit.
That's not really that good too. You put it between 8 inch and it's supposed to be bluish. It's jumping.
But it's not.
It's not that strong. And when we tested when we tested the resistance was a little bit too high. So that's not really very good.
Don't sound friendly either.
Another thing is also you want to test for longevity. Is it gonna give me a spark now or 5 minutes later? What happens when things warm up?
Expand.
They expand.
What happens to the resistance when the
Resistance goes up.
goes up? When things are warm, resistance goes up. So that's not really a good spark. So
You can't-
primary winding, secondary winding, either use a machine or test for the spark. Yeah.
I don't think you touch that.
Probably you'll burn your finger. You smell that? That's the air being ionized.
Fresh.
So if you touch that, probably gonna be zapped really badly. You burn your finger, you might die.
You might die, you might have a heart attack.
So the reason I put my hand behind me, I'm not touching anything, just in case. Electricity goes through by the screwdriver and through my body, at least doesn't have a way to conduct.
And don't
somewhere
Touch the
else.
ground, mister.
Huh?
Touch the ground.
If you touch something and let's say the ground and you for some reason this wasn't exploded enough, that's 10,000 volt. It's gonna go through your heart and it might kill you. So have proper respect for that.
A lot of respect.
This is the highest voltage you're gonna face in residential heating. And always use goggles. You never know. Something might fly off, part of dust. So these are the
Newer ones.
solid state. They're newer, the cheaper are like 40, 60 bucks. But again, either they work or they don't.
They're not dependable as those ones.
Yeah. So I've seen a lot of places where they had electronic ones and they would switch back to transformers.
Those aren't as efficient as those ones, right?
Nope.
Say that again?
Those aren't as efficient, right?
It depends. If they work, that's really good because they're cheaper and they give you the voltage, so that's fine. But again, the longevity, the life for warranty is not the same from what I've seen so far. They have resistant to moisture, they are electronic, solid state again, it has capacitor. Consumption is 30 to 40, 50 watts, which is not a lot compared to 100 watt, half the consumption. This is another second method, just a transformer without powering it up. So they want you, if you look at the transformer, it has a ground in it. And if you look in here, it will tell you what you're supposed to expect of resistance and how do you test the ground. So again, we're testing for resistance because we are thinking about the wire inside. So measure the resistance from each lead to the ground and they should be within 10% of each other. So let me do that. I'll do it this way. So this is my lead, this is my ground. And I got 1905. Kilo ohm. That's one lead. Let's look at the other lead. $11.09. That's not good at all.
10% of each other.
Yeah. This does not look like 10% each other at all. If you divide these by themselves, they're not the same. So you use all these splitters to test the transformer because it's around $200 or $150 for a transformer. You don't want to go to somebody's house and condemn the transformer, buy another one, and find out that it's not the cause. And having delayed ignition is very frustrating because what happens is the oil burner will turn on, then turn off again. Everything is running, everything is getting power, but there's no fire. And oil is very hard to ignite. You have to have the right mixture.
Can you flood it on accident and then not be able to ignite it without removing some of the oil?
Yes. And we'll talk about that later, how is flooding an issue and what you do to flood the system. And this is the first thing you do when you go to somebody's house and there's no heat coil. Ask them how many times they hit the reset button. Every time you hit the reset button, you're gonna spray some. Over time, the chamber will be flooded. The chamber is made of insulated material. And if you turn it on, you're gonna have a big fire inside the chamber. And it's gonna go for hours.
You should check yourself, even if you ask them, they tell you that they only did it like once or
You have to
twice.
refine it every time.
No.
They'll tell you that they
Yeah.
press the button and.
So that's why
Right up, right in front of you.
That's why the new property control will allow you to have 3 resets, then it will go into hard lockout, which means you cannot reset anymore. Something is really wrong. Consult the manufacturer. This is another way to test it, but again, you have to have experience to see the spark and what color the spark is. Otherwise, you're not going to be able to understand if it's good or not. This is a good spark. It's consistent. It's strong. It's blue. Yellow or orange is not good, and you have to keep it for how long? 5 minutes. See if the transformer is still going to operate in this wall. Then 15 minutes and watch for the spark. It should be, if it turns from blue to orange, then you have to
Pressing
change.
the leads in towards each other?
Yeah, so you can plug, you can put them close to each other and do that, or you can just hold a screwdriver to them, or you can put electrodes sitting on them. Another one that you can use is turn it on, leave it on, and put a clip-on meter on it. And the amperage should not change. So what happens, the summary of all this verbiage here is you turn it on and you put a clip-on meter and watch for the amperage drop. And leave it on for 10 minutes. If the amperage don't change, what does that mean? This transformer is not good because it's changing amperage as it heats up. 5 minutes, it should give you an answer. So these are the, how many methods do we have now? Either use a tester, look for the spark, measure primary and secondary resistance, measure each lead and ground, and compare with each other, and always you should be within 10%. What is the resistance you expect to have from the primary? The primary. 3 ohms, plus or minus 3 ohms. Secondary?
12,000.
12,000. So those numbers are important. They will always ask you in the open exam what is the voltage you have at the secondary. What is the voltage you have in the secondary? 10,000. Voltage.
Oh,
Voltage.
So,
that's still plus or minus 10%?
yeah.
Is this gonna be on Blackboard?
Yeah, it is in Blackboard. Okay? Any questions? So, for this lab, I'm gonna have you do all the 3 methods. You're gonna have a transformer and test it. Me and David will be there, and we'll take turns. Please have proper respect for that. Again, it's 10,000 volts. Be very careful, no jogging around. Try to have a steady hand to measure the spark. If you don't feel comfortable doing the spark, you can just do the resistance. I'm okay with that. Or you can use this test. So, that's all for testing transformers. Thank you.
Are we gonna